Welcome students. In this video, we will be discussing about the recursive approach to check if linked list is sorted. Already we have just discussed the concept of, how to check if linked list is sorted, and also we have the iterative approach of it. Okay, already we discussed the iterative approach of how to check a linked list is sorted. Now we will be taking the same iterative code, okay, and we will be converting that into a recursive approach. So this iterative approach code, we're going to convert it into a recursive approach code. Okay, fine. So coming here, first of all, we should start with same return type integer. Name of the function, let me take it as or is sorted. Recursive is sorted. And the argument, first argument is the same argument struct node star temp, which will take the address of the first node. Second parameter, let me take it as integer x. So while calling, the smallest integer value should be used. Smallest integer value should be used instead of x while calling the function. Then I enter inside this function. When I enter into a recursive function, the first thing that comes into my mind is the base condition. What is base condition? Base condition is some condition which is gonna stop or which is gonna continue the recursion, either way. So now always we wanted to see while loop only we will be converting into recursive. So coming to this loop, what is the condition? Whatever is the condition of the loop, you take the same as the condition of the recursion also. So if temp not equal to null and temp of data is greater than or equal to x. Okay, if this condition is true, then you can do a recursive procedure to iterate over the linked list. So whatever you have done here, that you can do. So what you have done here, you have changed the value of x and also you have changed the value of temp. So when the arguments are changing, when the arguments are getting changed, now what I will do is I will make a recursive call. R is sorted of. So instead of temp, we will be passing temp of next. Instead of temp, we will be passing temp of next, and instead of x we will be passing temp of data. So the same function we are again recursively calling it, and instead of temp we are passing temp of next, instead of x we are passing temp of data. So the whatever this loop is doing, the same will be done by this piece of code also. So let me close this conditional statement. So this recursive part will do the same as what this while loop is doing. Okay, fine. Now else, if this condition, if it gets fails, if the condition is getting failed either because of null or because of like a temp of data greater than or equal to x, whatever the condition, okay, whichever condition is getting failed, you just enter into else part and you just simply verify at the time when this condition is evaluated to false. Check what is your temp having. Your temp, if it is having null, definitely your linked list is sorted because you reached the end. So temp equal to null, then return 1. else you can just please return 0. You can return 0. So else we are closing, and this also we are closing function. So we have written a recursive approach for the same function. We have written a recursive approach for the same function. Now we will be tracing this recursive code. We'll be tracing this recursive code with the help of main memory stack part to understand whether this recursive code is going to perform the same as iterative code or not. So we're going to trace each and every line of it. Okay, so let us take it, and we'll just move to next one. Okay, now we will take main memory. So we take main memory. This is main memory. Okay, so main memory is actually divided into 3 parts. Main memory is divided into 3 parts. Okay, part 1, part 2. So this is topmost part, this is the downmost one, this is the middle part. So coming here to the topmost part, this part can be called as heap memory. This is called as heap memory. Then the middle part can be called as stack memory. Then the bottommost part is called as code section. It is called as code section. Okay, these are the 3 parts available. Okay, 3 different sections. Now we already know why is this heap memory required, why is stack memory required, what is code section, right? So once your snippet is executed and it is converted to bytecode, object code, or when it is converted to zeros and ones, .exe file, that .exe file consisting of only ones and zeros will be taken and it will be stored inside code section of main memory, and then execution will be proceeded. Now whenever a function gets called, something called as activation record it will be created inside the stack memory. So let us consider that initially this function is called with the address of the first node and also with x, the very lowest minimum integer value. So when this function initially gets called, activation record will be created inside stack memory, and inside that activation record, how many blocks we require, how many arguments, 2 arguments. Totally we are using only 2 variables inside, so 2 memory blocks we wanted. So let us create 2 memory blocks inside this activation record. Memory block 1 minute, memory block 1 and memory block 2, and the name of the first memory block it will be temp, and the name of the second memory block will be equal to name of this new, the second memory block is equal to x. Now what is going to be the value of temp and value of x initially while calling? Okay, so that we can just verify with this. So what is the address of first node? Address of first node is 200. So 200 will be the initial value of temp, and x will be having some minimum integer value. So temp is gonna store address 200, whereas x will be having some negative 32789. Once the value gets stored, then I will enter into this function checking whether temp not equal to null. Yes, temp is not equal to null because it is having 200. It is not equal to null. And temp of data, 200 of data, is it greater than or equal to x? X is a negative value. We will check with what is temp of data. Temp is 200. So 200 of data, 23. So is 23 greater than this negative value? Yes, of course. So what we have to do? We will, this conditional statement is evaluated to true. So I will enter into this conditional statement, and recursively the same function again we are calling. When the function gets called, as I always say, activation record will be created inside stack memory whenever a function gets called. So because of this new call, we are creating one more activation record, inside which there will be again two more blocks, block 1 and block 2. So block 1 is having the name temp, block 2 is having the name x. Now tell me, what is the values that you are passing instead of temp and x? Instead of temp, we are passing temp of next. So 200 is temp, 200 of next you are passing. So what is 200 of next? 200 of next is 330. So now the present value of temp will be 330. Now coming to the value of x, temp of data, which is 200 of data. What we saw, 200 of data was having 23. So that 23 will become the new value of x. Okay. After storing these two values, again I will enter into this same same function. I'll start checking if temp is not equal to null. Yes, temp is holding 330. It is not equal to null. Then temp of data is greater than or equal to x. Temp of data is actually 330 of data. So we'll see what is 330 of data. 330 of data is 34. That 34, is it greater than or equal to x? So temp of data, which is 34, is it greater than or equal to x value 23? Yes, it is true. So temp is also not equal to null. Temp of data is also greater than or equal to x. So you enter into this conditional statement where you have the recursive call. So the same function is again called. So when the function is called, activation record have to be created. So one more activation record will be created on top of the existing activation record. Inside this activation record, two blocks will be created, one for temp and another one is for x. So first one we will be creating for temp. The next block is for x. Now what is the argument that we are passing? Instead of temp, it is temp of next. Instead of x, it is temp of data. So instead of temp, we have to be passing temp of next. What is temp here? 330. What is 330 of next? 330 of next is 450. Okay, so 450 will be the new value of temp. 450. What is the value of x? X is holding temp of data. What is temp? 330, the previous temp, 330. 330 of data, we already know that it is 34. So 34. Again, I enter inside. Temp not equal to null. True. Temp of data greater than or equal to x. X is having 34. Now temp of data. What is temp of data? 450 of data. 450 of data is 45. So which is definitely greater than or equal to 34. It is greater than 34. So both these conditions are evaluated to true. So I enter inside this block and a recursive call is here. So recursive, first of all, it's a function call. Function call means definitely activation record will be created. and how many blocks that function have to take? 2 blocks that function will be taking. So one block 1, the next one is block 2. So the name of block 1 is temp. The name of block 2 is X. So instead of temp, we have to be passing temp of next. So what is temp of next? Temp is 450. What is 450 of next? 450 of next is 600. So 600 will be stored here instead of temp, 600. And instead of X, what is temp of data? What is 450 of data? It was 45. So 45 will be here. Now next one. Again I enter here inside. I'll check if temp not equal to null. Yes, temp is not equal to null. And temp of data greater than or equal to X. Temp is 600. What is 600 of data? 600 of data is 56. So 56 greater than or equal to 45. True. So when both condition evaluated to true, we will enter inside where we have a function call. So we need to be creating one activation record for it, and inside which we want 2 memory blocks actually. One is for temp block, the other one is for block X. Okay, so it is having, first block is having temp, second block is having X. Now instead of temp and instead of X, what is getting passed? One is temp of next, other side it is temp of data. So temp of next means 600 of next. So what is 600 of next? It is null. 600 of next is null. So now our temp will be received with null, and what our X will be receiving? X will be receiving temp of data, which is 600 of data, 56. Okay, 56 will be stored. Again I start from first line. If temp not equal to null, no, that condition itself becomes false because temp has become null. So if condition, this condition is evaluated to false, so you will be entering into else part. In else part, what you are having? In else part, if temp equal to null, return 1, else return 0, else return 0. So I want to tell, there is a mistake here in the total recursive code. I'll tell you what it is. When you return 1, that 1 cannot be directly returned to the main function. You have intermediate activation record, so it can be sent only to the next immediate activation record. It cannot be directly sent to the main function. So from this current activation record to the next activation record only it can be passed, and also this activation record will get created. So this one, okay, this one, if you check, this one will be returned to the previous activation area, the recursive call place. Instead of recursive call, you will be having this, you will be receiving this one, because of this call only what happened, this return 1 is executed. So instead of this recursive call, what happened, this one will be received. So whichever one is received by the recursive call of this activation record have to be sent back to the next, even every activation record to reach the main activation record. So what we should have done is, before this call, we should have just provided a return statement. So you return 1, which is received by your recursive call. Then your recursive call will again return it back to the next activation record. So this whatever one, see, the one that we sent from the top activation area to next activation area will be sent to the next immediate activation area because of this return statement. It will be again sent to the next activation record, then to the next activation record, then to the main function. So if you need to receive this one in the main function, then you have to give a return statement here also before your recursive call. Okay, and also before returning that one value, there itself activation record will start getting deleted one after the other. Okay, fine. So finally, that value which is written here will be carried out to all the activation record with the help of this return statement. Okay, fine. See, what I'm trying to convey is that every activation record is having a recursive call. Because of that recursive call only, the next activation record is being created. So from here, if a return statement is executed, that return value will be sent to the recursive call that happened in this activation record. If that value have to be returned to the next activation record, then this recursive function should return. So that is why we mentioned a return statement before this recursive call. Okay, fine. So in the next video, we will do the implementation of both iterative as well as recursive approach. And also in the next subsequent video, we will be doing the time and space complexity analysis of the same problem. Right? Thank you. Thank you, students.